Hello everyone. In this video, we will learn about the priority scheduling algorithm. Priority scheduling. Here, a priority number that is an integer is associated with each process. A priority is associated with each process and the CPU is allocated to the process with the highest priority. Equal priority processes are scheduled in first come first serve basis. Some systems use low numbers to represent the lower priority, whereas some systems will use low numbers for representing the higher priority. The main problem is starvation. It is because the lower priority processes will get postponed and they will never execute. The solution to this problem is aging. That is, as time progresses, we can increase the priority of the processes. Let us see a problem in the priority scheduling algorithm. Actually, the priority scheduling algorithm is of two versions. So one is non-preemptive priority scheduling and preemptive priority scheduling algorithm. If it is a non-preemptive priority scheduling algorithm, when a process is running, we cannot interrupt that process because of the arrival of a higher priority process. So the running process will allow to continue and finish its execution. Whereas if it is a preemptive version, the running process will be interrupted and then you will give chance to the incoming higher priority process. Now we are going to solve this priority scheduling algorithm using this preemptive version. That is, if a process is running, because of the arrival of a higher priority process, you will interrupt this running process and it will give chance to the higher priority process. So we are going to use this preemptive version and then solve the problem. The first step. The first process to arrive here is P1. So time 0, we have only one process, say P1. So the Gantt chart will begin with the process P1. That is, it begins at time 0. That is the only process available here. So it will get executed. But at time 2, we can see there is a process P4 which is arriving, but the priority is 1. In this problem, let us assume that the low number indicates the highest priority. So in this case, P4 is having a higher priority when compared to P1. Now, in the meantime, let us note down the burst time of P1 as well. So P1 has executed for 2 milliseconds. So the burst time of P1 instead of 11, it will get reduced to 9. So that also you can note it down when we are solving the problem. The next step is here we are allowing P4 to continue. Now P4 will continue till time 5. You can see at time 5 there is a process P2 which is coming in and you can see the priority also. Priority of P2 is 0, which has the highest priority among all the processes. So in this case, we'll stop this P4 and we have to allow P2 to continue. So P4's burst time, we can see from 10, it has reduced to 7 because it has executed for 3 milliseconds from 2 to 5. Now the process P2, which arrived at time 5, has the priority say 0, which has the highest priority. Now comparing that process with the other processes, say P3, which has arrived at time 12, and P5, which has arrived at time 9, the priority of P2 is higher. So we will allow P2 to continue. So P2 begins the execution at 5 and it ends at 33. The burst time of P2 is 28. So beginning at 5, it will end at 33. Once P2 gets over, out of the remaining processes, we need to schedule the highest priority process. Now, out of the remaining 4 processes, when we see, we can note the priority of P4 is higher, that is 1 when compared to the other processes. So P4 is allowed to continue. It will continue till 40. That is from 10, it got reduced to 7 earlier. So 33 if it begins, it will execute till 40. Now P4 gets over because there is 0 burst time remaining. Now out of the remaining the processes, 3 processes P1, P3 and P5, again we have to consider the priority and schedule it. Next to P4, we will schedule P1. So P1 will start at 40 and it will end at 49. The burst time of P1 is 0 now. The next remaining processes are P3 and P5. Out of the remaining 2 processes P3 and P5, P3 has the highest priority. So we will schedule P3 next. So we are scheduling P3 next. So till 51 it will execute and there is only one more process which is remaining, that is P5. The next process to continue is P5. This is the Gantt chart for the given problem. Let us see the waiting time and the turnaround time for each and every process. The waiting time of P1 is 38. This is the period during which P1 was waiting. So 2 to 40, the P1's waiting time is 38 and P2 waiting time is 0. The arrival time is 5 and it started its execution at 5. So the waiting time is 0 and P3 arrival time is 12 but it begins its execution at 49. So the waiting time is 37. P4 arrival time is 2 and it started its execution at 2 but in between there was a break. It completed its execution at 40. So this period P4 has been waiting. So 5 to 33. That is 28 milliseconds is the waiting time for P4 and P5. The waiting time is 42. That is arrival time is 9 and it started its execution at 51. So the waiting time is 42. The average waiting time is 29 milliseconds. Coming to the turnaround time, it is the difference between the submission and the completion time. P1's arrival time is 0. It completed at 49. So turnaround time of P1 is 49 milliseconds. P2's arrival time is 5. Completion time is 33. So 28 is the difference. P3's arrival time is 12. Completion time is 51. The turnaround time is 39. P4 arrival time is 2. Completion time is 40. Turnaround time is 38. P5 arrival time is 9. Completion time is 67. The turnaround time is P5. So the average turnaround time is 42.4 milliseconds. In this video, we have learnt about the priority scheduling algorithm. Thank you.